Video, I'll be sharing how you're going to solve BFS and DFS along with code. So starting with the code, we have from collections, we are importing DQ. Why we are importing this? Because in BFS and DFS, a queue is being made. The order is different for BFS and the order is different for DFS. So first we need to understand this code and we need to understand the graph in this code. Karachi is our first node, which is connected to Lahore and Faisalabad. So if you look at here, we have Karachi and it's connected with Lahore and Faisalabad. After that, we need to check Lahore and Faisalabad. Lahore is connected to Islamabad, Karachi, and Multan. Lahore is connected to Islamabad, Karachi, and Multan. And next, we need to check Faisalabad. Faisalabad is connected to Karachi and Multan, means Karachi and Multan. Next, we have Islamabad that is connected to Lahore and it's connected to Peshawar and Peshawar is connected to Quetta. Now, I will add the connections as well for clarity. So how our BFS basically moves. BFS basically works on first in, first out approach, meaning that in our queue, the first element that is being added to the queue will be removed first. And it's a level by level approach, means that in this we have 1, 2, 3, 4 levels, depending on how your graph is. It basically searches like this. It searches from the starting node. It checks each and every neighbor. In this scenario, we have 2 neighbors. If the neighbors are more, it checks each and every neighbor and add it to the queue until or unless we have no neighbors left. Then it moves to the next level. And again, the same process is repeated. It checks for the neighbor until or unless it has no further neighbor, then it moves to the next level. So basically, what's happening here is that we have a queue, and in that queue, the first element that is being inserted in this queue is Karachi. And it is very important to note that in BFS and in DFS, the start node is very important. In this scenario, my start node is Karachi. If my start node would have been Islamabad or would have been Lahore, then the output will be totally different. So the whole result of traversed graph is different. In this scenario, Karachi is the first element that is being added, and in BFS and DFS, we are searching for a specific goal. In this scenario, let's suppose that I'm trying to move from Karachi to Quetta. So how it basically moves. After Karachi will be the first element that will be added and will be the first element that will be dequeued from first. After Karachi, we add Lahore and Faisalabad. And remember that basically 1 element out and 2 elements in. This is basically the strategy that is being followed. So when Karachi is removed from the queue, 2 elements are added, which are Lahore and Faisalabad. After that, we have something like this, Lahore and Faisalabad. When Lahore is removed from the queue, other elements are now being added, which are Islamabad and Multan. Now we add here Islamabad and Multan. For simplicity, I'm just writing short forms. As we can see from here, Multan has an adjacent Faisalabad. It should be added on top, but it's not added because it's already visited, so it's not added. Next, every neighbor has been checked for Lahore, so there are no further neighbors. So it moves from Lahore to Peshawar. meaning that when Faisalabad is when basic in next step, when Faisalabad is DQ'd, the next element that is added is on top of Islamabad and Multan, we have added Peshawar. And after Peshawar, we have added the last, when this will be DQ'd, this is Islamabad will be DQ'd, then Quetta will be added on top. So this is the process of your BFS search. Basically, the meaning is it searches level by level, meaning that for every node, it checks its every neighbor. From Karachi, it moves to Lahore and Faisalabad. After Lahore, it moves to Islamabad and Multan. Then there are no further neighbors as this has already been visited. Then it moves from Islamabad to Peshawar and it has no other neighbor. Then it moves from Peshawar to Quetta. That's the process of our BFS. And if we check on our code now, basically we are defining a function that is named as BFS. It takes two arguments. One is graph and one is start. Graph, why we're taking graph? Because it's considering this graph and it has a start node. As I told earlier, the start node is very important in our BFS and DFS because the whole traverse outcome result is different. I will show that as well. Initially, our visited is equal to set as empty because there are no nodes that are being visited. Queue, in our queue, we are basically dequeuing from start. It means that first element that is added in the queue will be removed first. Then we are basically adding our start, meanings that whatever element we are starting with, we are adding it to the list of visited nodes. Then in our BFS, the logic is that we have a while loop, meaning that we are moving until or unless the whole graph is being searched. Node is equal to q dot pop left. Basically, it starts from the left, then it moves to the right. And this step is being repeated until or unless we have a neighbor. For neighbor in graph, when there is a neighbor in your graph, then the element is being added in the queue and one element is being removed and the next element is being added. If neighbor is not visited, first it's checking that if neighbor is not visited, then add that neighbor into your set of visited list. And this basically process repeats. Q.append, basically in this step, what we are doing, we are basically um, adding an element to the right side of the DQ. Okay, so this is the logic of our BFS. So if we look at our code, we are basically giving BFS the argument as graph and start node is set as Karachi. When start node is set to Karachi, when we run this code, we see our results Karachi to Lahore, Lahore to Faisalabad, as we have seen here, Karachi to Lahore, then to Faisalabad, then Islamabad, Multan, then Islamabad, Multan, and Faisalabad was already in visited list, and then to Peshawar and Quetta. So the order is basically dependent on our starting node. If we have a different starting node, then our resultant outcome will be different. I'll show you this. As if we have Islamabad as our starting node, then the outcome will be different. It will be like this: Islamabad to Lahore, Lahore to Peshawar, Peshawar to Karachi, Karachi to Multan, Multan to Faisalabad and Quetta. In this code, we have not set a specific like goal. So it moves from start node till it's all the nodes are being visited. So we can set a goal node as well. Let's suppose if we have a goal set on Quetta. So if we see the goal is achieved after 1, 2, 3, 4, 5, after 4 nodes are being visited. So starting node is important here. Now let's see our BFS code.